Okay guys, welcome to your homework. This is round number 2 because I already did this morning and it didn't record a thing. Let's get it going. So this is your foldable, obviously unfolded. You have 3 examples, 1, 2, and 3. We are going to go through all 3 of them and how to do them. Today we're talking about area of composite figures. Composite figures is just when 2 or more shapes are put together to make one big shape. Now I'm going to break it down in steps for you, but the basic gist of it is to separate the figure. So here, to find the area of the composite figure, we'll break it down into steps. Step 1, separate, into smaller, familiar shapes. And we say smaller, familiar shapes because obviously you don't know how to find the area of an ice cream cone, but you do know how to find the area of a semicircle and a triangle. So separate into smaller, familiar shapes. Make sure they don't overlap each other. Step 2, find each area. And step 3, add them up. Add them together. So we're going to follow these 3 basic steps just for your own convenience. You guys have all the area formulas right here for yourself. Remember, with the trapezoid, we break it up into 2 triangles and a rectangle. All right, example number 1. So in this example, we have 2 shapes, although it might not be entirely obvious now. If we section this off, we then have a semicircle in the top. And in the bottom, we have a triangle. You can see as I'm highlighting the edges, that's the triangle. And in order to find our total area, we need to find the area of each piece. So we want to find the area of a semicircle and then the area of this entire triangle. There's no reason to find the area of this one and then times it by 2 when you could just find the whole. Let's start out by finding the area of the semicircle. I like to notate that we're doing area of the semicircle by putting the little shape of a semicircle next to it. Since it's a semicircle, we will do 1/2 pi r squared. Again, we're going to keep everything in terms of pi until the very, very end. So here we got area equals 1/2 pi. Let's identify our radius and our diameter. If our radius is 5, that means our diameter is 10. And in this case, we're going to be using the 5. So 5 squared. Area equals 1/2 pi times 25. Well, what's half of 25? We know that half of 25 is 12.5. So now, for the area of the semicircle, we have 12.5 pi. All we have left is to find the area of our triangle, which is base times height over 2. Our base of our triangle, since it's upside down, would be this entire length, which is our diameter. So the base of our triangle, that's a triangle, is 10. The height, or how tall our triangle is 8. Remember, this slant height isn't how tall our triangle is, but this height is. So our height is 8 and divided by 2. From here, we get 80 over 2. And therefore the area of the triangle is 40. To find our total area, we just have to add them up. So our total area would be 12.5 pi plus 40. We can leave this in terms of pi because that's the hard part. Putting in your calculator and getting a decimal answer, that's the easy part. Now we need to calculate the perimeter. When you're calculating the perimeter of the semicircle, you're used to doing the semicircle and then adding back the diameter. But in this case, do we need the diameter back? No, we don't, because it's asking for the perimeter of the shape. So we need the straight edge, and the curved side. Let's go ahead and start out with our curved side. Move the camera. We've got C equals, we've got a semicircle, so we're going to do 1/2 pi d. So we have c equals 1/2 pi times our diameter, which is 10. Then 1/2 of 10 is 5 pi. Now the straight edges, I'll put SE, are going to come from our highlighted yellow. This here, this marking indicates that these two are the same. So if this is 9.4, this is also 9.4. So our straight edges, or SE, are 9.4 plus 9.4, which gives you a total of 18.8. Now we need to take both our curved edge and our straight edges and add them together to give us our total perimeter. So our perimeter would be 5 pi plus 18.8. Again, I'm going to leave it in terms of pi because that's the hard part. The easy part is putting your calculator and rounding. Now, example 2 is rather nice because it's already sectioned off for you. So we have our triangle at the top. Then we have our rectangle in the middle. Then we have, we'll do an orange, this trapezoid at the bottom. See how easy it is to identify the colors once they're color coded and the different shapes? First, let's start finding out the area of our triangle, which is base times height over 2, which means we have a height of 9. Now our base here, we're going to get from this length below. So it's 15 centimeters. So we have 9 times 15 all over 2. 9 times 15 is 135 over 2, which gives us 67.5. Now we need to change colors, and we have our rectangle. So area of the rectangle, again, is base times height, which is 4 times 15, which gives us 60. All right, doing pretty good so far. Now we're up to our trapezoid. Our trapezoid we're going to break up into 2 triangles and 1 rectangle. If this length here is 15, that means this is 15. Now if this whole length is 18, well, that means that there's 3 left over for each base of the triangle. So 3 divided by 2 is 1.5. So we have a base of 1.5, a base of 1.5. Let's go ahead and find the area of these triangles. Sorry, floated away a little bit. So area of the triangle, base times height over 2, gives us a base of 1.5 times our height of 4 all over 2. So we get 1.5 times 4 gives us 6 over 2, which is then 3. So that means that the area of this triangle is 3, and the area of this triangle is 3. So we have times 2, because there's 2 of them, 6, for a total of our triangles. Don't forget about your rectangle in the middle, which is a 15 by 4. So area of the rectangle part of our trapezoid, base times height, is then 15 times 4, which is 60. Now, if you put this together, you can either choose to put it together now or you can put it together later. But if I want to say the area of my trapezoid would be 60 plus 6, which is 66. You don't have to do that step, but you can. Just makes it easier when you go to find the total area. So our area total would be our triangle plus our rectangle plus our trapezoid. So it'll be 67.5 plus 60 plus 66, which would give us a total of 193.5 centimeters squared for our total area. All right, if you're getting the hang of it, give this next one a try. If not, stick with us. We're right here and we'll do it together. All right, break out those colors. We've got our triangle on top. We've got our rectangle in the middle. And we've got our parallelogram on the bottom. All right, let's start out with our triangle on top. So we have base times height over 2, which is then 7 times 4 over 2, 28 over 2, which is then 14. Then we have our rectangle in the middle, which is base times height, which in this case it actually isn't a rectangle, it's a square. I didn't even realize because it's 7 by 7. So 7 times 7, which is 49. Then we've got our parallelogram on the bottom. Don't overthink these. I noticed you guys were overthinking these in the classwork. Area of the parallelogram is just base, which is 7, times your height, which is 3. So base times height, 7 times 3 is 21. Now that we found all of our areas, we can now find the total area by adding our triangle, our rectangle, and our parallelogram, well, our square. So we have 14 plus 49 plus 21, which gives us a total area of 84 yards squared. And that, my dears, is how you find the area of composite shapes, or shapes that are made up of more than one shape. Colors are your friend. Be careful, make sure you write everything down, and just, keep track of your work. All right, thanks, guys. Good luck. Have a good night.